Yeah, what do we got? 9. Can someone message me in the Sprint channel and just tell me, am I coming and transmitting okay? You can hear me okay? The screen share is all working fine? Cool. Yeah, I had a little bit of trouble the other day, as I kind of maybe alluded to, but y'all are stuck with me again from here on out. But it was a good day for Beach to step in, and I hope y'all got a lot from it, because Beach is absolutely amazing with C. He taught RC back in the day when I went through in CS7, so I definitely have a lot of respect for Beach in that area, in every area. But definitely was a good day for me to have that happen in terms of the value that y'all probably got out of him doing it. That said, like he said, it's the same material that we go over. But as I always say, everybody loves Beach. All right, we got 16 people in here. Ryan, is that about what the norm should be? I'm not aware of where we're at, but I don't think much has changed since last week. And then 2 weeks ago, we only lost one person, so I'm thinking this is about good right here, correct? Okay, I see Ryan's typing. Yeah, I was just thinking this was around about the right number. I just wanted to confirm with you, so give it just a few more seconds and we will get started. So today, we're going to go over a pointer review, and I'm going to do a quick survey while we're waiting. And then, as I indicated, we're going to go over memory allocation. Hopefully everybody watched the videos and you've kind of got a head start on that, or you've got an idea of what it deals with a little bit just from the past, and what we've talked about. And then we're going to talk about a little bit about data structures, arrays, and how they're represented in C, and structs, and a little bit of how they work. So make this anonymous. Gonna add choices. Option A, totally lost. We'll say option B, shaky, but getting there. Feel pretty solid. Capital R. Star. And be honest, we're going to go back over this a little bit today. And like Beej was saying earlier in the channel, and like it probably couldn't be stressed too much, and I can tell you from personal experience going through this, it's a matter of reps. Just like anything else, this just normally takes, especially if this is your first exposure to it, which it is for most of us, it just takes the reps, and with reps, it will come just like everything else did. But this is a difficult subject. It's probably one, at least when I went through, that was some of the most confusing material for me and my classmates. So, a day with it, a weekend of going over it. Don't feel bad if you don't have this down. Anybody that has this down completely probably has prior experience with it, or it just happened to be their thing, or you're a rock star. So let's do that. And I have it as anonymous, and I will send to the channel. And everybody take a moment to fill this out. I'm just kind of curious where we're at, both for myself, for the instructors, for Ryan, and just kind of get an idea. $10 votes. Should have about 5 or 6 more people that need to vote. If you haven't voted yet. But it looks like the general trend is some shaky, but getting there. And that's fine. I mean, we don't We don't want to see totally lost, but if that's the case, it's not unusual. And we're probably not expecting to see anybody say I'm a rock star, but it's good to see a few people feeling pretty solid about it. But we're probably, I think the instructional staff would agree, probably at where we would expect to be at today. And a lot of today's work, when we're dealing with memory allocation, when we're dealing with structs, will reference back to this, your work today. If you've already started working on it, or if you've taken a look at it, or if you haven't, the work that you do today will continue. Anything you do in C will continue to be very heavy on this. So like I said, it'll come with time. If anyone's got a microphone on, can you turn it off right now so I don't have to go back in manually and mute everybody? Just give a little bit more time for anyone else that hasn't voted, and we're going to get started. Oh, knock it off, Kai. Yeah. All right, so assuming everybody's in here, we've all voted. And like I said, it looks like we are pretty much all in the same place. And I can guarantee, I don't remember it perfectly, but I guarantee I remember we were all in the same place or totally lost at no fault of the instructional staff. Like I said, Beach did a great job with it, but it's expected. So we're going to go over a little bit of review today, and kind of true to how I do things and how I run things. A lot of this today is just going to be a general overview. We got a lot to go through in terms of code. I'm going to be coding out things in the Python tutor again. If you're having trouble, I know there were some issues the other day with errors and a lot of things, use the help channel, work through that. But for the GP, we're going to use the Python tutor where we can walk through it, and we've got a nice environment set up. If anybody has any trouble with your own environment that we've got set up, you need to get with the help channel, get with your PM. If you can't get a hold of your PM, you're always free to message me, but use the resources that are available, and we'll get that figured out. But today, this is going to focus on the code itself in terms of the GP. All right, so start out here with a straight up address of and dereference. So we'll say int main, and I need to put in void. We'll say type int x equals 12. And hopefully the types y'all have down a little bit more solid than you do the pointers, but types can be a little bit confusing and are equally important. And remember our semicolons, just as I was. And if you see me make a mistake, or if you think there's a mistake, please speak up in the channel. Just like Python, where I tended to leave out some of the colons at times, I tend to forget about the semicolons at times in C. This certainly is not a language that I use often. It's been a long time since I was heavily involved in it until I was preparing for it the last week. But as always, feel free to speak up. And if you have any questions, feel free, of course, to ask. So we're going to do a print statement here. Make sure we have line. And we want to print X. And then we have the return statement. Anybody out there in the channel want to say what you think? We'll step through this, but what do you think the final return, the print statement, is going to actually print for this? Signing an integer, type, we're using our pointer. $99. Anybody have any other ideas? Are you thinking 99? The consensus? Anybody else? Speak up if you think it may be otherwise. I'm not sure. I got to run through the execution, so we'll see. And everyone, if you're already not, I would encourage everyone. 66. Brad, what makes you say 66? Okay. I was looking, when you said that, I looked over at the code and I'm like, well, maybe if you turned it upside down. Exactly what I was thinking. I looked over at it, I was like, how in the heck did he get 60? I had two other things in mind that people may come up with, but I was trying to figure out the 66 and asking him to explain why I was trying to waste some time looking over at the code next to the channel here. Maybe pointers flip numbers. So let's visualize the execution. Of course, this is going to take a few seconds to run. We're not going to take a lot of time going through all the individual steps. But as we step forward, of course, the great thing, once again, yeah, you can't be too sure these days. I'm going to be dead honest. I'm not 110% sure. This is the third time I've been through C. The first time was as a student. The second time I was a section lead when we went through C, I believe. So I was a lot more hands-off with the PM type stuff. And this is the third time, and this is really the time that I feel like I'm starting to get a really great understanding of it. So like I said, it just takes a lot of reps. And anybody that's got a question, anybody that's got any kind of statement they want to make, feel free to make it here in the channel. That's what we're here for. And the other thing, feel free, please, I encourage everybody, to be in Python Tutor. Like I said, I'm going to type out all of the code, no cutting and pasting. And when, go through it line by line, please, go along with it, play with the code, see what things do. This is how you learn. So as we step through it, of course, we start to see the pointer right here, and then we go to our print statement, and what are we going to get? And we move forward one more with the return, and the print output was 99. So unfortunately, Brad, you were wrong. Does everybody understand? Does everybody understand why this is happening? This is a pretty basic example. Like I said, we've got a lot of new stuff to go through today, but we wanted to step back through this just to kind of get everyone's mind moving, refresh anyone's memory that may have been a little weak on it. Or Addison, Nedham, let's see what y'all have to type. Yeah, this is a great tool. We knew of it when I went through C. I wish I would have used it more. I've used it a lot this time around. I mean, the first time I've really used it heavily. What would have happened if we didn't include X and just had... Kai's asking, what's the point of return 0? Because we're not returning, in line 1, we have int main, we have void. We're not actually returning anything. We just have a print statement, just the same as in Python or in JavaScript when we actually have a physical return from a function. Here we're just executing a print statement. And if I take the return 0 out, for example, let's see what happens here. Now we've got you can see here, we've got the 99. I'm at step 5 of 5 though, and I have no print output. Kai, is that clear? Ryan just summed it up a lot better than I did, that it's the exit code and 0 means it's successful. Yeah, we're going to go back to that. So I'm going to go back in and add I'm seeing that I'm saying that Addison answered it. And Nedham, where were you wanting to change the code at? And what were you specifically wanting to do in line 5? Oh, there you go, like that. Let's see what that'll do. Ah. Thanks, Stephen, for putting that up. And then we step through it right here. P equals X. So now we've got 12. And I love their little emoji they've got down in the pointer. And now as we're stepping through, we're throwing an error on step 4. So let me go back and look what people have typed. Remove void from main. Does that mean it's pointing to nothing or garbage? Or what? Addison. Yeah, I mean, you just in this case, the best way I can word it, yeah, you're. It's just invalid syntax with line. If we went back through and edited the code, and you're still going to get an error in here. And yeah, Addison. I mean, it's invalid syntax, and C doesn't like it because you don't have a place in memory. So it's simply just going to throw that error and do nothing. We'll go ahead and move along to the next one because we've got a lot to do. We're going to use a function to modify a value in the caller. Like I said, if you have more deep questions about this, it's a great thing to bring up in the Q&A, where you can bring up real specific questions, and everything's structured around answering those type of questions. Let's see. Into here, and above this, we're going to say void set 99 int p. Yeah. So my internet cut out a little bit. Let me share my screen again. Is my screen sharing where it's right? Somebody type if they can hear me okay. Okay, is that picking up now? We're good. All right. Sorry about that. They are at the moment still repairing the damage that happened the other day. I was hoping it was going to go all the way through this, but let me make sure it's still recording. So it is still recording. Okay, and everyone's seeing me type on the screen. It's fine. Kai, let's see Kai typing. Okay, let's go. So can anyone explain what's going on line 1? And we will say P equals 9 int main void you're passing an int pointer as a parameter, correct? We've just named it set 99. Yeah, function that does not return anything. Anybody else have anything to add? So here we are just going to say int x equals 12, int q then we will invoke set 99 q, and we'll do a print statement as usual. So we have our new line and X. Nah. What's wrong with line 10? That fix it, Kai? Like I said, I'm going to forget them. I'm the first person to admit it that I will forget them and probably forget them often. So looking at this, I said we just got a function modifying a value in the caller, line 13. I see. Yep. Thank you, Nedham. So that this should be the correct code now. What's this going to print out when we step through it? The Addison typing. Let Brad type real here before. I'll print 99 again. Addison, we'll get back to that. I'm going to go ahead and run the execution. Anybody have any idea of Addison's question? Why we're assigning pointers as int? Step through this. Now we've got 12 in the int. Got our pointer, and we're invoking set 99. So we jump back up because we've invoked our function. Now we see the pointer. Where's this going to jump down to now when I hit forward again? Somebody type. And hopefully somebody's typing along with this and can just move forward to the print. Let's see. Well, that doesn't count. I wouldn't. Yeah, I'm going to jump down to the print, and now we're pointing to the 99, the Eileen line 13. And when we move to the return statement, we will see our print output is 99, as Brad was saying, and as it should be. Does everyone see why this happens? Yeah, Addison, I see you just changed your, you got, if we didn't assign it up there to the type of variable it was, or if we didn't do any type of assignment whatsoever for the pointer, we would end up throwing an error. Like if we just, let's see, edit this code. What could we put here to test that out? Just leave it blank, or would I want to put void? Put void. Ah, CP undeclared. Now you want to try it with the character, okay? I was going to, like that, Brad? Yeah, let's see what happens there. I don't think it's going to like it. Yeah. And we see what happens. Yeah, it does work, but at 12. Now what's going to happen when we go to line 13? Well, actually, we're going to jump back up 4, and now we'll go to line 13. And then we'll, on the return, it actually does print it out. Anyone have any idea why that works? That's a good question. If anyone's interested in that, to ask in the Q&A, because I know, I don't think, I won't even say think, that Beej will do a better job of explaining that than I would. And I'm going to keep moving along because we've got a lot still to cover. We've got all of Malloc. It's already 45 minutes past the hour. One thing I wanted to point out is if we change this to int, what could we change this to right here? What could we change this Q to and have the exact same output and would do the exact same thing? Anybody have any idea? And Chi, let's see what happens with Chi's. Some people agreeing with them. Why is that, somebody? Why is this going to work? Yep, Chi. And I think I've got everything repaired that I did earlier, so let's visualize the execution of this. A lot of good talk going on. Let's step through it. And on the return, guys, stop, Addison. What have you done? We actually get the 99. Is everyone still just as confused with the pointers as you were when we came into here today, this morning? Yeah, and that's what this is for. I mean, this is for, you just got to sit there and do this, watch it, do it on your own, do it on your own some more, and do it on your own, 20,000 more times. Well, hopefully not that many. And it's just playing around in here. Nedim says question, X address. Carlo. See some good discussion going on here. you want to transform X from value to pointer, use at. I'll let y'all type, and then I'm going to asterisk. It was a bit confusing since you set a pointer with it. I'm going to go back and look back through this real quick, what everyone's typed, because there was a lot typed here this last reps day. So Kai, type what you're thinking. As far as you're saying, you see what's happening here with what we did and why it worked. And a lot of people thought it was going to throw an error, but it didn't. No, you saw earlier if you don't initialize a pointer, what happens? We saw that in the previous example when we played around the code, right? With the code, right? It's about 50. And yeah, Brad's got it there, what he's saying. That declares a pointer and then subsequently sets the value at the address the pointer is pointing to. I'm going to go ahead and give you everyone a break now because we're going to move on to Malloc, which I don't want to just go 5-10 minutes into it and then cut it off. So everyone take a 5-minute break. You can keep thinking about this, grab your coffee, and it is 52 past the hour, so at about 57 up here on my time, we will meet back and move on to the Malloc and the Structs. I'm going to pause the screen share here for just a second. So everybody take 5 minutes. We'll get started right before the hour. All right. It's about 57 minutes past the hour. I'm going to give just a second for everyone to get back in. And we are going to start going over Malloc. All right, everybody should be getting back in. Stephen, I saw you were typing. Were you trying to say something? Just some sweet jokes, some sweet, sweet jokes. Yeah, lay off that sugar. Funny that we talking about sugar because the languages we've dealt with in the past. Somebody tell me how JavaScript, why we don't have to worry about malloc and free and that type of thing where we're allocating and deallocating memory in JavaScript. Just as an example, there's plenty of other languages we could use it as an example, but why in JavaScript do we not have to worry about malloc or some kind of similar syntax that does the same thing? Somebody type there, Netum. And James, the garbage collector. That was the answer I was looking for. A lot of the languages, when we're not dealing with a low level language, are handling all this, as we would say, under the hood. But in the case of C, we've got to take care of it. And so in C, as I'm hoping everyone watched the video, what are the two commands in C that we use to allocate this memory and to free the memory? It's not a trick question. Yeah, Malloc and free. You're missing one L, Netum, but yeah, you've got the idea. MALLOC for memory allocation and free for free memory. One thing you need, if you IntelliSense stopped working, one thing you need to keep in mind, and a lot of these demonstrations that we're doing are just for the purpose of demonstration. If you don't free the memory, it's not going to necessarily affect, we've got a lot of memory available, especially with the machines that we're using, this language, this goes back a long time. But why do we need it? We need to get in a good habit of always freeing the memory when we've allocated memory. When we're done using it, we've become our own garbage collector is kind of the best analogy or you know, what was that word you used the other day, Kai, when you called something cute? I've still got a screenshot of that. You know, if, you know, using a cute little line, you know, we're functioning as the garbage collector now. So every time we allocate memory, we need to free it. What would happen if we didn't free it and we were running a complex program? Maybe say we weren't running some of the machines that we're running now. What would eventually happen? Kai. Let's see what Kai's got to say. Kai's always got something to say. Seg fault. We don't have unlimited. I mean, the simplest way I can explain it, or I think of it, is we don't have unlimited memory, no matter what we're dealing with, whether we're dealing with a computer from 1989 or 1979, or we're dealing, yeah, you're going to run out of memory. It doesn't matter if we're dealing with the machines we're using now, or probably the machines we're going to be using in 50 years. I don't know if I'm going to be around in 50 years. A lot of y'all will be, but I'm a bit older than most. But the point is, we don't have an unlimited amount of memory, and we need to free that memory when we're done. Another thing that we're going to see in here, when we're allocating that memory, what's something we're going to have to keep in mind if we're allocating a type, or let's say if we're working with an array, and we've kind of got a little bit of an idea how an array works in C from the other day and from the videos that we've watched or from moving ahead. What's one more piece of syntax that we're going to deal with other than malloc and free when we're dealing with this memory allocation? Nedum's typing. No, not type. Think in terms of bits and bytes. Realloc. There will be cases that you will see very soon. We're not going to cover it today, when we do have to reallocate memory, because when we allocate memory, it is static. Another nice thing that JavaScript does under the hood is, like, say we declare an array, we can just keep building on that array. And there's a lot of stuff, some inefficiency that goes on under the hood, but we don't have to worry about increasing the chunk of memory that we have got dedicated to that array. Say we have an array of 5 indices, and we end up adding on 5 more indices. We don't have to worry about what's going on with JavaScript. But what I was looking for was size of. So we'll see that here in just a second. So we're going to say int p equals, and we'll use malloc, and we will say size of, probably put int here since we're using an int. Makes sense. Have our pointer. It's 12. We're going to return p here instead of returning 0. And then in the main, we will say int main void. And we're going to invoke make 12. And pipe right. We're just going to invoke the function itself. We don't have to pass anything to it. We're going to print. Careful not to forget my quotations. So for overall, we're returning 0 again, but what do you think that print statement's going to do? What is that print statement going to do? Somebody type. Print 12, Addison. I'm going to go ahead and visualize this execution. I have to step up the time a little bit. We're already at 7 past the hour. Executing, so we walk through. Calling it, so we're going to jump back up. Now I've got a pointer. Now pointing to 12 and returning. We jump back into here. And then we jump to the return and we see what Addison thought of 12. Does everyone see what's going on here? I messed up somewhere. What did or didn't I do? We got it to work, but there's something we're missing. I'm not missing anything. Maybe it's a trick question. Am I missing something or not? Trying to make people think. Think back to what we've talked about, what you learned yesterday. Yeah. And once again, this shows this will run with you can allocate the memory up here. We could allocate a whole lot of memory up here. But after the print statement, I'm going to edit this code. What would we free? We need to free something. What are we going to free? X. Let's make sure that works. We'll visualize the execution. And there I went. Visualize the execution again. Fix the following error. We're going to step through it quickly. Same thing happens that happened before. We get to the print statement. We get to the free. Actually get the print output. And we don't have any problems when we return, and we're at step 9 of 9. Does everyone see this is a pretty basic example of it? We're just trying to show, you know, the allocation of the memory and the printing the memory. Does everyone see what's going on here? From what we've just seen, from what we saw in the videos earlier, or what we worked on. We saw it either today or yesterday, and what we've worked on. Does anybody want to play with the code at all, change anything to see what it would do? Nedham's typing. The size of is based on the type. We're giving it a type. We're dealing with bits and bytes here, and the simplest way of thinking about it is that we're allocating. Let's see what you're typing here. In this case, an integer is 4 bytes, so we're allocating 4 bytes. Is that what you're asking? Okay, we will see that here in just a second, Nedham. When we get to a piece of code, we're going to have one more piece of code, and then what we will do after that will answer. You should answer your question directly, okay? If we need an array of 50 elements, we're going to have to deal with the 50, and we'll see several different syntactic ways of dealing with that. You're not just out, you're allocating not for the integer itself. You're not allocating for the pointer. But we had a single integer in this case, so we just needed 4 bytes. Does that make it a little bit more clear? And then we'll cover the rest of your question here in just a few minutes. Nedham, anybody else have anything real quick? I do need to move along. Okay. So what we're going to do here, we're going to use a function to make a symmetric free call, give you something to think about. And I'm just going to kind of run through this real quick here. Int P. We're going to allocate the memory, malloc, size of int, return P, which we did before. And we're going to have a second function. It's called free12. It takes in the pointer as an argument. So free P, and then we'll have int main void here. Say int x equals, and we will call make 12. And we're just calling it make 12. If that's confusing, we're calling it make 12 because of line 5. There's nothing about the memory allocation itself that has to do with 12. I think that's a little bit confusing. Maybe it was just confusing to me, but we're going to have a print statement. And then we're going to call free 12 here. So we have a symmetric free call. And we return 0. And I'm going to look at what somebody was typing. I'll look at what you typed in just a second. Let me look back over this. P malloc size of int 12, return P. We have our free call, calling free P, int main. Call make 12. We have a print statement. We free 12. And pass in our proper. Visualize the execution of this. This all looks good. That doesn't look good. What should this return? Somebody answer quick. What do we expect this print statement to do? Fixing line 22 here. We fix the error. What is everybody, what's going to print out here? Brad. Yeah, we're looking for 12 again. So let's step through this real quick. I'll make 12 pointer. I think it was Addison, your friend has appeared here again. Why? I don't know why that's doing that. Yeah, it's just 12, Kai. That's what we're supposed to be printing out. But does someone know why it didn't print this? Ah, good catch, Brad. I don't know if any of y'all saw me do that, but I actually went back up in line 5 and took that out to see if somebody would catch it. And it should run like this now. Good job on catching that. Fix the error, so let's run through this again. And I'm just going to step through all this. And when we free, if we step back, we have nothing. Then we move past the print line and we're freeing. We have no problems. We're going to go through the free. And we see it steps through the free 12 function call that we make. And we get the same output. Anybody have any idea why that's doing that? Is Steven typing? No. Anybody have any ideas what? Anybody know why we're getting this for the pointer? Yeah, exactly. That's all I was looking for. Exactly, Addison, because we freed it. So when we get to this point in the program, it's just this visualization. The Python tutor is doing that. I was just hoping somebody would catch it. We freed it. If we hadn't freed it, would we have that happen? Stephen typing. Slack is wrecked. It's kind of like my internet. It's because we free it, and if we don't free it, we wouldn't come across that. But it doesn't matter. This is what we want. The whole point of all this is showing how the memory allocation works, showing that you've got to base your size of based on the type that you're using. It has to be that way, or you're going to risk having a lot of problems. And we're going to see now a little bit, and we're going to go back to I think Nedham's question earlier with the arrays. So the take-home lesson here is that arrays are just syntactic sugar for pointers and pointer arithmetic. So if we edited this code, we can just say, show you an array real quick. Those of you that might not have seen one, we're just going to declare int a 5 equals 11, 22, 33, 44, 55. Print statement. And we're going to say A2. What are we going to get out of this print statement? What should we get out of this print statement? 33. Let's see. Yeah, that wasn't an accident. Or that was not on purpose. Excuse me. I will admit that. Another example of me missing something. So it's executing. Thank you for correcting me on that. So we step through it. And we get 33. So knowing what we've watched from the video, what we've just seen, just kind of intuition, can we use that pointer to change the value of one of these indices? Yeah, trick questions everywhere. That wasn't a trick question, though. I honestly just missed the closing paren. So here we can say int, and we're going to make a pointer. That would help not to do that. Yeah, and Nedham, you're kind of ahead of the game, but that's what we're getting. That's what we're getting at, and what you were asking about earlier. And the arithmetic versus your first example is pointer arithmetic. The second example is the exact same syntax. It is just a little bit simpler and cleaner way to put it, but it functions the exact same under the hood. What do we expect to get from this print statement, though, that we've currently got? Yeah, 99. So we fixed our error that we had. Brad, let's see, that 99, this, whatever. And then we'll, so here, and we got 99. We edited this code. What happens on line 7 with what I'm doing on line 7? And Brad's kind of already alluded to it, and I'm hoping. What's happening on line 7? What's happening on line 8? Yeah, we're just doing pointer arithmetic. So this right here would be just the same as saying like A at 1 becomes 999, and the same here for 4. And if we printed let's just print 4 and see what we expect to get. We should get 123. See if I didn't make any mistakes. Line 6 equals P to the. Why is it throwing an error? So what should I have had there then? What did talking about here? Take this out, Kai. Talking about that, doing it that, like that. Ah, yeah. Let's try to run this again and see what happens. Fix the error. Let's see what it does. And I'm going to step through. And then for our first, we should get 99, and then we would expect and hope to get 123 here, which we get. Kai, you are absolutely correct. I just threw something stupid in there to see what it, if somebody would catch it. Pointer multiplication. And what's the other way? Nedham, you kind of brushed on this earlier. What can we do in lines 6, 7, and 8? Yeah, he was the first person to point it out. What can we do in lines 6, 7, and 8 to simplify this a lot? Something I want to do on each of these. What could I do? No, not commas. Yeah, just use our familiar array syntax that we've got from other languages that we are much more familiar with. Unfortunately, it works here. So if we do this, we should get the exact same in these print statements. Let me make sure I didn't make any stupid. When will we use pointer arithmetic syntax? Well, think about what could pointer arithmetic do? I mean, this is pretty static what we're doing right here, but you could do some dynamic things with pointer arithmetic, right? This would be a good question for with the time that we've got left. Yeah, exactly. It's dynamic, Brad, and there's all kinds of answers to that. And if anyone's got a question about that, that would be a great thing to bring up in the Q&A. Step through this at 99, and we hope for 123, and we do. Nedham, what did you want to do? You wanted to take out on line 4, edit this code, and you just wanted to point at A. We'll execute that. Let's see what it does. And it does work. The details in that we're going to move past, but that is a, yeah, Kai, exactly. It's pointing to the first. Exactly. Honestly, I don't know. I don't know particularly, and this is not a trick or anything. I don't know which one is actually preferable or if it even matters. That's a good question for Beach later on, straight up. That's something I have no idea exactly why you would want to use one versus the other, if there's a more correct way to do it. But yeah, being explicit, seems like it would be a good idea, but I don't know if there's any downfall to doing what we just did. I'm going to go ahead and move on. But yeah, it is the same, and that's something we were going to go over. But like I said, I don't know a real clear answer to that. But the plane A points to the zeroth element, most definitely. All right. So, any questions that had to do with this, or let's move on to Structs. Before we move on to Structs, I'm going to give everybody about 2 minutes just to sit back, get your eyes off the screen, grab a quick glass of water, cup of coffee if you got some ready, and literally in about 2 minutes we'll get started again. I don't see if Brad's typing something, but I'm going to make this real brief. Okay, long story short, and we don't have a lot of time to go through this. When you allocate memory for an array, notice we appear, if you're going to have an array and you're going to be manipulating that array, you're going to have to allocate the memory for that array. So if you got an array of length 50, like somebody mentioned earlier with the memory alloc, you've got to allocate 50 spaces based on the type of whatever is going to be in that array, the memory for that. If it grows, it does not do what JavaScript does, where you can just keep on adding to that. You've got to actually, someone brought up the realloc earlier, and you have to actually reallocate the memory to make space for, you've got to know ahead of time or guess a good amount that doesn't get carried away of what you're going to do with that array. And you'll see this in some of the exercises that you do. And that's where the realloc comes into play. But yeah, you most definitely, when you're dealing with data structures, you do deal with memory allocation. Deej is typing. Maybe I just said something incorrect, but let's let Deej.
No, I'm answering an old question. Just keep on going.
Okay, so you don't have any issue with what I'm saying here, correct?
I've been typing, so to be honest, I haven't quite heard.
Okay. They were asking about the allocation of memory with an array, and I was just explaining that if we're going to have 50 indices in the array, we've got to allocate that memory, and that if we don't, or if say we end up needing 60 down the line, you've actually got to reallocate the memory for that.
That's all good.
Okay, yeah, it's not dynamic like it is in JavaScript, and this is a statement I'm making. You've got to reallocate the memory. You will see this in your exercises and the things to come, but I want to go ahead. Like I said, I'm going to give everyone 2 minutes to step away, and then we're going to jump on Structs real quick. So I'm going to pause to share. Everyone literally at 37 minutes and 30 seconds past the hour, we're going to get done with the Structs, or get started with the Structs. About 20 more minutes. Go ahead and share again. And Beach has put together, I kind of figured that was what he was addressing. And I'm reading this myself because I didn't know. Anybody that's here should be getting back in. Like I said, it was just a quick break. But I will admit I was very comfortable in JavaScript. And when we were doing Python, I'm not uncomfortable in C. Like I said, this time around, I had a lot of time because y'all had a build week to look at things. Some of the things I pass on because we just have a lot to go over today. And it would be better brought up later. Like I said, I'll admit when I don't know something, and right here is you get your hour with. I'm not an expert on C. I'm not an expert in JavaScript either, but I'm certainly not an expert in C, and that's why you get your time later on with the expert in C to take advantage of these real particular questions. But everybody, if for some reason you're not looking in the channel, Beej, you can look back at this. Beej gives a great explanation to what I didn't know earlier that got to, that was brought up with those two lines being equivalent. I'm one of the most expert people in C I know, but I'm still not an expert in C. But yeah, while we're doing this, there's going to be some questions. I'm just going to straight up tell you I don't know the answer. And I'm glad that Beej was in here and jumped in on this and was able to provide this. We don't have a lot of time to go over this right now. Y'all can talk about this more later, but definitely know this is here. And this would be, this type of thing is a great thing for later on in the Q&A. And I know I've probably said that a few times, and I don't mean for it to be like a cookie cutter line of it being the great. Addison's got a question. I'm going to go ahead and get going again. I'm going to let Beej type while I'm getting going, and then we'll talk a little bit about structs. Beej, I'm going to ask you about that later now that this got brought up.
Yeah, to be honest, I can't. It's been a long time since I've looked at that because I remember having that exact question ages and ages ago. I'll do a little bit of research right now and see if I can actually find out the answer for it.
Yeah, and I'll definitely hit you up and ask you one way or the other about it later. This is an example of something that just went over my head, is the particulars of this.
This piece of information about the type of address of A versus address of A sub 0, this is something that like a tiny fraction of 1% of C developers know the answer to. Like, this is esoteric, way out there knowledge. Everybody just uses just the name of the array by itself as a pointer to the first element, and that's it. So,
okay, yeah. And I'm glad that you were in here, and it's good that this was that people were catching this. And like I said, it makes me feel a little bit better because that was one that just totally had me when this came up. But glad you jumped in, and I'll chat with you later about that as well. And maybe we can go in and fix this if we need to make some changes. All right. So structs, hopefully everyone watched the video on this, and Addison saying it seems to run the same in the tutor window either way. Yeah, it was running the same, but I'm going to go ahead and move on with the structs. You got there. You got 1,000 million, 100 billion answers on Stack Overflow. What's a struct remind us of? A dictionary, or what's another word that that may come to mind. But yeah, great answer, an object. Something that's in my notes that I didn't actually know is that I've got something that says the entire type name is struct space whatever. Struct is part of the type name, and if Beej is in here, he might be able to just throw in a line about still in here. He could throw in a line about this, but I'm assuming you could invoke it with that, but you can shorthand it with the struct. I honestly don't have any clue, but if not, somebody can ask about that later, and I'm going to go back over that later. I remember thinking about this, and I just kept moving along, and I had no idea.
Yeah, it has to do with it's more being formal about the type name. So we're used to saying like leg count is an int and name is a char pointer, like you have up there.
Right.
But if we declare a new struct animal, those two words, that's the type name. Just like int is the type name, char pointer is the type name, struct animal, that is the type name. So goat is type struct animal. And a lot of people tend to shorthand that and be like, goat is type animal. But yeah, that causes problems potentially later on if we decide to rename the type or alias the type. So if you have the word struct out there, that's the type of the goat. Goat is a struct animal.
Cool. I don't
Just
even
pays off now. It pays off later to be formal about it now. Instead of saying goat's an animal, say goat is a struct animal.
Yeah, cool. Well, I just learned something. I don't even remember that from when we went over it. I'm sure you said it and it just flew over my head or something, but I don't even remember that piece of info. And I meant to look back on it, and honestly, I just never looked back on it, but that's good to know.
No, nobody remembers a piece of info the first time. You gotta go through it several times.
So here what we've got is we're declaring a struct of the animal. And we are kind of going back to our types now where we've both got, I've had an error right here. There should be a semicolon after this. Or you got the char for the name and the type and the int that we've been using for the leg count. And then in our int main, we're just declaring or invoking a struct animal, goat, and using the typical dot notation to name the goat and give it a leg count. I don't know if anyone caught, I accidentally gave it 5 legs there for a second. But and then a print statement, and without really using any time on asking what the print statement, obviously we're going to expect goat and 4 to come back out of the print statement. You're going to see a lot more of this. This is just a basic intro into, see, at this point we have nothing in the pointer here. We'll step forward in this code. An introduction to structs, and like you said, you know, they look a lot like a dictionary and they look a lot like an object. They're fairly limited in somewhat limited as compared to what we're used to dealing with, but this is what we've got in C. I think somebody were talking the other day, like what Java and JavaScript was and what like C# was to C or something to that effect. But, you know, we're seeing on a really low level this type of a data structure here. And as we keep stepping through it, we're seeing obviously the characters are all building out there. Don't forget about your terminator at the end. I remember there was a question about that, but if you don't have that, you're going to have problems. So very important. That, I think it was when you were reversing the string the other day, some people were having some question or issues. And then if you didn't terminate your string like that, of course, the character being the primitive type string not. We keep stepping forward. And then when we come out of the print statement, we have goat and 4 as we expected. So I don't know if anyone's got any basic questions about that. I think between the video and just kind of what we know to this point, that should be fairly self-explanatory, and you'll get a lot of reps as we move through. Anybody have any questions about what we've covered right there? Okay, so after this print statement, we're going to do something a little bit different here. Just what's other than the dot notation to access the name, what else could we use? There's something else out there. No, not bracket notation. That good guess though. Array notation. Two characters. It's not something we've used in another language here. And this is just going back to pointers. This isn't really getting to what my question was just a second ago. I'm going to do two print statements here. Look at what everyone's typing in just a second. I'm looking back over what I've got here to make sure I've got everything right. Kai, when you've inadvertently kind of got, yeah. Oh, not even. Oh no, you've got it. Yeah. It's called the arrow operator. You said earlier array. Didn't you type array notation? Yeah, you said array notation. But if we visualize the execution of this, we should expect to see on line 19, if this would ever turn over. We can step through the code. This print statement, we get goat 4. And then we have our next print statement, and we should expect to see what here? Somebody tell me what we expect to see. Goat. And there we go, we've got goat. And the whole point of this being, we could go edit this to this, can execute it again. Piece of shit. I could type it right. I think that should fix it. Once again, the parens are getting me. Fix the error, step through the code, get our goat 4. Don't have any problems, and we should get goat. And this, there's nothing more to this other than we just kind of revisited a little bit with pointers, but we're just showing a different way. I like this for some reason, but once again, I don't know. Is that what you wanted, Brad? I don't know, and nothing that I don't know if there is any sort of subtle difference or reason or whatnot. I got you, Brad. Yeah, it's a good point. And it's kind of annoying, that error there anyway. I don't know really. It is definitely the same notation. I don't know if anyone's going to ask the question, which I was thinking someone was going to say, well, why would we use one versus the other? What's the difference versus one with the other? We're really kind of up to the end of what I was covering today. I don't know if Beej is still in here. If you wanted to comment on that real quick, or that's something they could go over, or y'all could talk about in the Q&A if anyone wanted to know.
I am here, but only with half an ear. What was the question again?
Dot notation versus the arrow operator. Is there any, I was kind of just brought it up myself because I expected someone to ask, what is any subtle difference? Why would we use one versus the other? And I was just kind of preempting it with, I don't really know the answer to that. Nothing I've reviewed or remembered from what I learned. Is there any difference?
Yeah, the short answer is if you have a pointer to a struct, then use the arrow operator. The dot operator only works with structs. It does not work with pointers to anything. So if you want, you can, if you have some pointer to a struct, you can type that, what I've just typed in chat, but that is unwieldy. So C programmers use this syntactic sugar instead.
Gotcha.
So those two lines I've just typed are equivalent, and the second one is just more readable. The short rule of thumb, like I said, if you have a pointer to a struct, use the arrow. If you have a struct, use the dot.
Cool. Yeah, well, I'm glad that you were still in and covered that. That's just another little detail that had slipped me, and now that's come up. I don't really have anything else, and we're right at the end of the time. So I covered it the other day, but I'll just go back over it again today. The repo that we were in is a 2-part repo. You should have gotten through there was five pieces to that 2-part repo. You should have gotten through the first 3 yesterday. Some of you got to the 4th and 5th, which covered what we covered today. And then there's stretch. I think there's 2 items in stretch, and I think some people had gotten to that. But today the idea is to finish the MVP on this repo, get to the stretch, definitely play around, use Python Tutor, experiment. Yeah, if you have problems in your environment, like I said, bring it up in the help channel, bring it up with your PM. We're going to head to lunch right now, and I've got my prep time for the next few hours for the upcoming GPs, but I always kind of sort of keep an eye on Slack no matter what, even though maybe I shouldn't be. But if anyone needed to message me about any particular questions, if you couldn't get anything in the help channel, but there is PM channel coverage as usual. I'm sure everyone remembers that during lunch, even though we just came out of a build week, but we've got assigned PM coverage at all times. So there's help there. Tomorrow and Thursday, we will be going over processes. And Beej is for anyone that might not be looking in the channel, Beej is looking at the help channel, and he's adding questions to the facts. And remember that with the facts, that's a lot. Somebody asked the other day, you need to be reading the readmes on this. That doesn't include the facts. The facts, like I said, you can, in your text editor, you can definitely search them. And the eventual idea with the facts is to be able to answer 98% of the questions that weren't covered in the GPs, that weren't maybe covered in the videos, or maybe were just glossed over, or something that you forgot. The facts, a lot of it will be in there. Be just saying, if you haven't looked at the facts, please do. The facts are long. They are exhaustive. They have a lot of great information in them. I learned a lot going through the facts. And I think maybe I misspoke that it's not even a question about just like Sean said the other day when he chimed in, I don't know how to say this a nice way, but read the README. And someone asked, does that include the markdown with all the facts? And no, technically, you should just think of the README as being required. And if you don't, and you come up with a problem, that problem started with you failing to read the README. But the facts definitely are something that should be looked at, and anything that B just put time into is well worth putting your own time into of going over. Like I said, we'll be doing processes for the next 2 days, and we'll go into a new 2-day repo, and then we'll, of course, have our sprint on Friday for that.
I can also add here that remember that part of your job as a developer, and this is going to be what it's like at work, is to marshal all the resources you have. And so knowing what resources you have at your disposal is step 0 on that. And so even if you don't like read the FAQ cover to cover, for example, if you just skim the questions, at least then in the back of your brain, you'll have like, oh, wait a second, did I see that in the FAQ somewhere? At least that piece of information will be in there. And so as a professional developer, you have all kinds of resources that you can bring to bear on solving a problem. At the end of the day, your boss is just going to be like, hey, we need this done by the end of the week. Go get it done. And you're going to be like, okay, it's just me, and we're going to just get it done. But you got to figure out, like, what do I have? I can use this, and I can use that, and I can use this. At Lambda School, you've got a whole pile of resources here that you don't have at work. You've got PMs, you've got TAs, you've got the help channel, you've got instructors. Everybody's like standing by to help out, but you'll still have to take that first step and figure out what it is you need help with. So Marshall, at your disposal. There's plenty here for you to get through all this stuff.
And so, somebody was asking about the facts are in the repo. I mean, it's just fact.md. Gotcha. Yeah, it's in the intro to C. It's just right here, the fact.m markdown. Anybody have anything else? We're at the hour. It's your lunchtime. Go ahead and take off. Get a breather. And I'm going to go ahead and kill the recording. Everyone have a good lunch. We went over a lot today. Like I said, a lot of times I'm trying to box these to an hour, but there was no way we were going to box this. And, you know, a lot of this, the current content that we've got, to an hour. So thank you for all bearing with me, and be sure and get going with the last half of this repo, and be ready for your Q&A that should be the same time as yesterday with Beej, and have your questions ready. So that's all I've got.